Hello everyone, my name is Daniel and I'm a programmer and an artist, and today I wanted to make a video about this new geometry node setup that I made that lets you make seamless tiling patterns. So if we, like this one here, if we render it, you can see this pattern tiles forever, and the cool thing about it is if we come in here and delete all of this, we can make any sort of pattern. You just put in some curves where you want a shape, and then it will figure out which part of the texture is closest to which shape and assign colors to it and all of that. So whatever sort of pattern you make, it should tile seamlessly when you render it. So you could make a crazy shape like that, or you could just make simple planks. You could make it so it goes all the way across and then just duplicate it up a bunch of times like so, and then you could make a texture that way. Anyway, so it's kind of an odd little tool, but if you're making materials or something, or you're making some custom textures and you want to generate seamless patterns, it can do that. So I thought I'd go through and walk through the node group and sort of explain all of the steps in the process and what it's doing, and then I'm also going to share this file. If you want to download it and experiment with it yourself, you're welcome to do that. So the basic idea is identical to how a voronoi texture works, if you're familiar with that. If you have a voronoi texture, what it's doing is it's creating a bunch of points. So for example, there'd be a point like right here, and then it figures out for each pixel in the texture what point it's closest to, and then it'll assign it a color or whatever based on that. So we're doing the same thing here, but instead of using the points created by the voronoi texture, we're going to use points from a curve object that we can edit here. So in order to make that work, we need to create pixels, so to speak, which I'm doing by just creating a grid of faces, and each face is essentially a pixel, so you can change the resolution of that here, the number of vertices. Anyway, so the first thing we're going to do right here is just do some work on our curve to resample it and make sure we have enough points to work on and stuff like that. So we're going to start with our curve object, our geometry that we can edit in the object here, and we're just going to resample it so that it has a lot of points in it. So you see the distance here is 0.005 between points, so those are very close together. And I'm just going to convert that to a mesh and then merge by the distance. And the reason for this is that if you draw curves that are overlapping, then where the two edges or curves cross, it creates kind of wonky results. So to resolve that and make sure it doesn't happen, I decided the simplest thing was just to split the curves. Because the colors are assigned based on the index of the spline, and because the curve continues across the intersection with the other curve, then they have the same idea and therefore the same color on either side of the other shape that's splitting it. So instead of doing that, I thought it made more sense in most cases wherever two curves cross, just to delete the intersection. So the way we can do that is after we've created a bunch of points in the curve and then turn it into a mesh, we can merge them together, and then we can delete any vertices that have more than two edges attached to it. You can see here at the intersection there's 3 edges attached, so those get deleted, and then we can convert that to a curve. Then for assigning the colors and everything to our texture, we're going to need to know the IDs or the indexes of these curves. So we're just going to take the index, evaluate it on the domain of the spline, and then we're going to capture that attribute so that it's saved in the curve here, and we can use it again later after we've converted it to a mesh again or things like that. Then I'm just going to set the position of the curve to be the position multiplied by x and y, but not z. That just makes sure that it's flat. It doesn't have any height to it. So if I was to come in here and pull this curve up, you can see it's up in the air, but after setting the position, it's flattened. Then we're just going to turn this geometry into an instance. So that sort of merges it all together internally behind the scenes. This is now like an object inside of the object, sort of. It's an instance. And then we can duplicate that entire instance as one piece instead of duplicating individual splines and things like that. So we're going to duplicate the element of the instance, and we want to duplicate it 9 times so that we can put 1 on each quadrant around the center. And that way we can create the tiling effect. So then we need to set the position of these duplicates so that they go around the object. And the way we can do that is by taking the index, duplicate index, doing modulo 3, so that'll go 0, 1, 2, 0, 1, 2, 0, 1, 2, and then dividing the index by 3 and flooring it, which will go 0, 0, 0, 1, 1, 1. So then we've essentially converted the index into a row and column coordinate, and so then we can plug the row into the x and the column into the y, or vice versa, I guess, and then we can scale that by 2 because the area that we're working in here is a 2 by 2 space. And then that ends up being set off like this. So then we just subtract 2 from the x and the y. Oops, subtract 2 from the x and the y so that it's centered on the world origin again. And then we realize the instance so that it's one object again. And then so that we can sample it, because we're going to, in a second here, create a grid of faces or pixels, then we want to sample values for. We have to convert that curve to a mesh so that we can sample from it. You can't sample the nearest you can sample the index of a curve, but you can't sample nearest from a curve. So we're going to use sample nearest, and then we're going to sample the index that we get from that nearest lookup. But what do we want to sample that on? Well, we want to create a grid. And the grid should be a little bit bigger than the size of your texture. So the size of the texture we're making here is 2 meters by 2 meters. So I'm going to do 2.5 by 2.5, just so that there's some room around the edges for the seamlessness of the texture to be perfect. Then what we're going to do is we're going to take that index that we sample from the nearest point from our input curves, and we're going to use that as the group ID to assign a random value to each face or pixel. So if we do a viewer on this, we can see if we do a named attribute called random, that we now have different values assigned to each face in the mesh. And this random island value just stores a named attribute named random with a random value in it. So that's what that node does. Now we could actually be done here if we wanted. You can see that all of the faces have a different color, and you can render this out. Oh, well, you can't render it from the viewer, but you could render it out and it would be seamless. But it does look kind of pixelated, which is fine. This could actually be better in some cases, depending on what you're trying to do. And if you wanted this to work, like have a closest filter on it, you could capture this random attribute on the face instead of on the point. And that would create a similar effect to using closest sampling in a texture. So anyway, that would be perfectly fine and work really well for certain cases. I thought it'd be interesting to try doing something, going a little further with it and creating actual shapes. So I split to instances with the same group ID, which is that index that we sampled off the curve, which splits the object apart based on that ID value. And then what I wanted to do is just smooth out the edges by converting it to a curve, essentially. So the way I did that was to delete everything except the outside edges, boundary edges. And the way you can do that is by looking at the edge neighbors. And if the number of faces around the edge is equal to 1, then it's on the edge, it's not in the middle. Because if it was in the middle, it would have 2 faces next to it. So then after deleting those edges, you can convert the mesh to a curve, and then once it's a curve, you can realize the instances again, which merges all of these separate planks, in this case, back together, essentially. Now, unfortunately, if you use the fill curve node, which was how I originally planned to do this, it loses all of the attributes that were on the mesh or the curve before. So that doesn't work because we need the attributes for the ID of each island so that they get the different colors assigned. So what I decided to do instead was to smooth out the edges and then to set the positions of the original vertices of the mesh to match where the edges of the curves had ended up. But in order to do that successfully, we need to move all of the islands apart so that they're not in the same space, because we need to sample based on proximity. And if you have 2 things in the same place, then it won't know which one to pick. So we need to move any 2 things that are close together up into a different area in the world so that when we sample the right one and not one that we didn't want. So the way we can do that is by taking the group ID for our instances and just plugging that into the Z component of a combine XYZ. And then we're going to set the position of our islands so that each island gets moved 1 up further on the Z axis. And we can do the same thing to our islands that have the faces. So if we look at the wireframe here, you can see this is our grid of pixels, so to speak. So we've moved both the grid mesh islands and also the curve outline islands the same distance up on the Z-axis. Then if we scale that vector by -1, we can use it at the end to put them back where they go. Then what I want to do is smooth out some of the sawtooth effect that you get from the boundaries being made out of these square faces. or pixels. So to do that, I'm just going to take the position into a blur attribute node and blur it like 6 times. That smooths things out quite a bit. And then I'm just going to turn it into a mesh. You can do that more times if you wanted it to be smoother, or you could also resample the curve you could do this like 6 times and then resample the curve to have a longer distance between points, and that would remove some of that waviness. But I decided that was good enough for what I was trying to do. So then once we have this curve, we're just going to turn it into a mesh again so that we can sample the nearest, same as we did before. We're also going to sample the proximity, and we're going to use that to create a distance from edge value. And that's all we're doing to these boundary edges. Now remember that on the z-axis, our pieces are all spaced out, and our grid pieces are moved exactly the same way. So what we're going to do now is go back to our grid version, and we're going to sample the nearest index of a point in that boundary edge, and we're going to set the position of the edges of our grid version to match the closest point on the edge of the smoothed out curve version. You can see it here on the corner, or right here, and those now match where the curve ended up after being smoothed. The other thing about the set position node is that we are setting only the boundary edges again, same as we did when we selected them to make that curve that we smoothed. We're using face count equals 1, evaluated on the edge domain. We're using that as the selection for where those get moved to, because otherwise you'd get this effect where every single vertex in the grid would get moved to the edge, which isn't really what we want. We want only the edge to move to where the curve edge got smoothed. Because that creates some weirdness in some places, like right here, where there's some stretched quads, we're just going to take the inverse of that boundary edge selection. So now we're selecting the middle. You can see if we view it. You can see when we're setting the position of the edge to the curve, we're using this selection here, and then if we take the inverse of that, it's everything except the edge, and we can use that to set the position to be blurred, which just smooths out. I mean, honestly, that's hardly necessary, but the idea was that it would just smooth out the edge a little bit if anything got stretched too much. Then there was a minor little problem that some of these edges were a slightly different color, which is why I had these nodes here. But I think since I actually went into this random island value and set it to be face instead of point, I fixed that a different way that's actually simpler. So I don't think we actually need this random at all. This was just accumulating the average of an island and then setting the color to that. But since we're doing it on the face now instead of the point, that's not necessary because they're all the same already. So we don't actually need any of that. So then all that's left to do is to capture this edge value, which I called slope. And that's just the distance from a geometry proximity node to that curve mesh, which is the outline boundary that we smoothed. So if we view that, here, you can see that it's 0 at the edges and it slopes up to however far away from that edge it's able to get. And that could be useful to create like mortar effects or create gaps between the different islands if you were making a pattern for a texture or something. So then the only thing that's left to do is we still have this offset on the z-axis, so we can just set the position to the inverse of that vector. So just scale it by -1. And that moves everything back to where it started. And once we've done that, I added this grid that's slightly bigger underneath it. So it's just a grid with 3 vertices, and I move it down by 0.01 on the z-axis, and then we join that all together. And that's just so there's a background behind it, because it can create these little holes at the corners. And so I just wanted something to be there if there was a little hole. So it just puts a black color behind it. And then finally, setting the material. The material is very simple. It just has that random attribute and the slope attribute, and you can plug any of them into the surface. So this would get you just the colors, and this would get you just the slope, or here I've sort of combined them together. And then once you have that, you can render it. I just have a camera here. It's set to orthographic with a scale of 2, which is how you make sure that the texture tiles perfectly. This has to be 2. Then you can render it, and whatever pattern you render will tile seamlessly around the edges. So anyway, that's just a cool little setup that I made. As far as how you could use it, you could take that color and plug it in. You could add it to a UV map to create an offset so that each plank in the texture or shape, so that each of these shapes, different colors, got a different part of the texture, so that you could just have one regular wood texture, and then each plank in on your surface will sample a different area of that wood texture without needing a wood texture that had the planks baked into it, if that makes sense. And then you could use the slope value over here to separate out. You could run it through a map range or something like this to create black lines in between. And you could evaluate that on the face as well if you wanted. So then you could like multiply. You could do it even less, like 0.001 to 0.005. Create these little black lines to separate out the planks. You know, multiply that over a wood texture where you offset the UV coordinates of each plank by this random value, which would just make it sample a different part of the texture. So I don't know. You can use patterns for all sorts of things. You could take the factor, just the grayscale value, and soft light or multiply that over a texture to create a simple planks effect. You could run this into a bump map texture as the height, and then plug that into if you had it principled here, you could plug that into your normal map just to create some bumps. So anyway, that's what I got for this setup here. There's a link in the description if you would like to download it and experiment with it yourself. You're welcome to do that. But yeah, that's all I got for this one. Thanks for watching.